Hello, everyone. Thank you for joining the webinar. My name is Marcia Fournier. I'm the West Region Vice President of Sales for Signify. So just for the ones who don't know Signify, our purpose is to unlock the extraordinary potential of light for brighter lives and a better world. We are the world leader, the #1 lighting company for connected LED and conventional lighting, not only for homes, offices, cities, communities. Our sales revenue last year was over $6 billion, or precisely 6.7 billion euros. And we do employ 32,000 people in over 70 countries. Our investments on research and development are always brought back, and we have over 4.2% of the sales reinvested in that area. We are very committed to diversity and inclusion, with over 29% women in leadership, and working on over 124 million connected lighting points in 2023. With that said, I'm going to pass it to Anthony, who is going to introduce our presenters today. Thank you.
Okay, hello everybody. My name is Anthony Callahan. I'm a key account manager in the US market. I've been supporting Signify's vast network of global integrator partners and sales agencies with color kinetics for over 11 years here at Signify, and I can tell you firsthand the importance of a well-planned and well-supported mock-up has on winning versus an ever-competitive color-changing lighting market. In the case of Coronado, this was a very complex temporary install, really both from the commercial side and technical side. It really took an army to get the job done, and both Brian and Brendon from our partner Foreman & Associates, who I'll introduce in a moment, are at the forefront of supporting this wonderful opportunity, driving us towards success. Before I introduce you to my friend Brian Ellsworth and Brendon McCartney, I want to take a moment to congratulate Foreman & Associates in general. They're our Signify lighting agency in Southern California. They're celebrating their 50th year in business this year. And they've also been a CK partner from the beginning, over 20 years ago. And we look forward to many more years of success together. So really congratulations, guys, to Foreman & Associates on that huge accomplishment. Now, I'm very happy to introduce you to our presenters, Brian Ellsworth and Brendon McCartney. Brian and Brendon truly exemplify the skills and qualities it takes to be successful in selling large-scale architectural color-changing lighting projects. They were both deeply involved in the Coronado Bridge temporary install, and they'll be sharing the details of what made this mock-up a success. So starting with Brian, I think I'm on the correct slide. Yep. He's been in the lighting industry since the 90s. He has been in specification sales with Foreman & Associates for 11 years, so a ton of experience that Brian has. He specified many landmark color kinetics projects over the years, over many different applications, from universities to major studios in Los Angeles. And a great example of a landmark project Brian helped specify was the iconic 2nd Street Tunnel in Los Angeles. Beautiful project, one of my favorites. We have a showcase on there as well. So great job with that one. Brian's also a father of two, enjoys museums, music, and exercise. So welcome, Brian. It's a pleasure to have you with us.
Thank you.
And over to Brendon. So Brendon McCartney, he's worked in various roles at both large lighting corporations, like Signify, and independently owned electrical contracting firms. So a lot of experience there in both avenues. He really has a wide range of skills in that technical specification area. That's really key to being able to support complex systems end to end. Brendon's also worked with color kinetics for many years. He has a wide range of successfully completed projects under his belt. He's also the father of two and enjoys hiking and playing guitar. So thank you, Brian and Brendon, for joining us today, and I'll pass it over to Brian. Kick us off. Brian, take it away.
Thank you, Anthony, and good morning, good afternoon, and good evening, depending on where you're joining us around the globe. I first of all wanted to thank YAP and the Signify Academy for the invitation to present to you today about the very interesting project of lighting the Coronado Bridge. When I do a landmark project such as this, the Coronado Bridge, I like to dig into the history of the project and the location. I think that's very helpful in terms of knowing the history and how significant this is to the city of San Diego and Coronado. So to talk a little bit about the history, in 1926, John D. Spreckles, who was one of the founding fathers of the city of San Diego, recommended that a bridge be built between San Diego and Coronado. But voters dismissed the plan. The U.S. Navy initially did not support a bridge that would span San Diego Bay to connect San Diego to Coronado. They feared a bridge could be collapsed by attack or an earthquake and trap the ships stationed at Naval Base San Diego. In 1935, an officer at the Naval Air Station at North Island argued that if a bridge was built to cross the bay, then the Navy would leave San Diego. In 1951 and 52, the Coronado City Council initiated plans for a bridge feasibility study. Between 1931 and 1969, the Coronado Ferry was the means of transporting people and vehicles between San Diego and Coronado Island. The ferry ceased operation on August 2nd, 1969, when the Coronado Bay Bridge opened for use. At that time, it was a toll bridge, and under California law, ferry boats are banned from operating within 10 miles of a toll crossing. By 1986, the construction fees were paid off on the Coronado Bridge, so the toll was removed, and the ferries began service again, but now only transporting people and bikes. By 1964, the Navy supported a bridge if there were at least 200 feet of clearance for ships which operate out of the nearby Naval Base San Diego to pass underneath it. To achieve this clearance was with a reasonable grade, the bridge length was increased by taking a curved path rather than a more direct path to Coronado. The principal architect was Robert Mosher. Mosher's job was to build a bridge that would provide transportation, allow ships access to the bay, and serve as an iconic landmark for San Diego. Construction on the San Diego Coronado Bay Bridge started in February of 1967. The bridge required 20,000 tons of steel, 94,000 cubic yards of concrete. To add the concrete girders, 900,000 cubic yards of fill was dredged, and the caissons for the towers were drilled and blasted 100 feet into the bed of the bay. The bridge opened to traffic on August 3rd, 1969, during the celebration of the 200th anniversary of the founding of San Diego. The 2.12-mile bridge ascends from Coronado at a 5% grade before curving 80 degrees towards San Diego. It is supported by 27 concrete girders, the longest ever made at the time of construction. As you can see from this picture, the bridge is not visible at night, except for the bridge deck only, lit with roadway luminaires. In April of 1997, the Port of San Diego released an international call for artists seeking qualifications of artist-led teams interested in developing environmentally friendly lighting concept proposals for the bridge. In 2010, a London-based design group led by Peter Fink was chosen. The winning concept envisions illuminating the bridge with programmable LED lighting in an energy-neutral manner using electricity generated by offshore wind turbines. In 2012, 2 years after choosing Fink's project team, the Port of San Diego cut a check for $75,000 to initiate fundraising in concert with the San Diego Foundation. A unique aspect of the lighting project is no taxpayer dollars will be used. Instead, it is relying on grants and private donations to completely fund the project. The design team chosen in 2010 is a combined European and North American group led by artist Peter Fink of Studio Fink, in collaboration with architectural lighting specialist Spears and Major Associates. led by Mark Major and Philip Rose, and Bureau Happold Consulting Engineers, led in Los Angeles by Stuart Brendon, and in lighting design support, Seth Eli and Landon Roberts. This team has practical experience in large-scale lighting projects and an extensive award-winning track record of creativity. In 2017, in my role at Foreman and Associates, I connected with Seth Eli and Stuart Brendon of the Bureau Happold Consulting Engineers Office in Los Angeles to provide stateside support for the lighting specification that was taking shape. In 2018, Landon Roberts came on board in support in his lighting designer role. The lighting design consists of 3 different color kinetics fixtures: the Color Blast, the Color MX Grays, and the Color Reach Elite. This mission statement is from the Studio Think webpage. The proposed San Diego Coronado Bay Bridge lighting project envisions a colorful, illuminated canvas across San Diego Bay, a programmable LED lighting installation powered from sustainable energy sources, which will create a unique aesthetic identity for the bridge and the bay after dark. It's intended to create a distinctive and timeless artwork for the region that will enliven the public environment and celebrate a recognized San Diego landmark. This project is being managed through a partnership between the Port of San Diego and the California Department of Transportation, Caltrans, which has jurisdiction over, operates, and maintains the bridge. The port provides leadership for the project and managed the selection process for the above-mentioned artistic, lighting, and engineering team. The San Diego Foundation is leading the fundraising effort. Other project participants include the City of San Diego, the U.S. Navy, and Benya Burnett Consultancy, who provided environmental impact data gathered during the 2020 mock-up to the California Coastal Commission. Foreman and Associates in Los Angeles and Signify Color Kinetics are providing agency and manufacturer support throughout the timeline of the project. ProCal Lighting in San Diego was the contractor who did the temporary installation work in 2019 and 2020. It is a very complex project, which will ultimately deliver a one-of-a-kind lighting experience for the citizens of San Diego and Coronado Island. In May of 2019, a lighting shootout took place over a 2-night period between Color Kinetics and a second manufacturer. 2 columns over land were illuminated with various color combinations. From November 8th to November 14th of 2020, 3 of the bridge's tallest columns over water were temporarily illuminated as part of a lighting field test to generate interest with the citizens of San Diego and for fundraising awareness. Our next speaker is Brendon McCartney, who was at ProCal Lighting in 2019 and 2020 and headed up their team that undertook the very complex task of temporary installation and removal of the lighting, and did so flawlessly. He will now share in detail about his role at ProCal Lighting during the 2020 mock-up. And with that, I will turn it over to Brendon.
So, as Brian just mentioned, lots of people involved with this project for over 100 years. So, I know I can say for Brian and for myself, incredibly honored to be able to speak about this, to be able to highlight the architecture. In some ways, it's highlighting all of the work that's gone into this bridge. And oftentimes, I do want to say before I get into the details, there's a lot of the construction workers and a lot of the people that assisted during the build, not only of the bridge, but of our installation. So there's a lot of unknowns that everybody pushes through, from design and engineering, all the way to the actual day of, let's turn the lights on. So hats off to all those people. And again, I'm truly honored. So we'll get started here. So what we're going to kind of run through is, again, this is a temporary mock-up that took place over the span of really about 1 month in 2020. And we're going to focus on the second phase. Brian had just showed a slide there. That was the first phase in which we rigged some strut and some Grays MX and Reach Elites onto a 180-foot boom lift to be able to demonstrate different manufacturers on piers that were over land. That was phase one. And that was really for the Port of San Diego to make a decision on which manufacturer to use based off of performance and support. And as you can see from his previous picture, there was an enormous amount of support from Signify. And so what was interesting about that is you had connectivity of the Signify representatives from Europe, from California, and then there was synergy across that entire approach. And that really led to the success of that and selection of Color Kinetics. So then when we get to phase two, this is say, okay, we want to actually capture data. We want to be able to understand from the design put forth what type of light excidents are we going to get off of the facades of the pier to ensure that we don't impede fish migration within the Coronado Bay. And so we took that approach that we used off of phase one and we applied it to over the water, specifically 3 of the piers, one gateway pier, Pier 18, Pier 17, and Pier 16. This is an image just showing you the safety devices that were being utilized, but also the extent of our contraptions, more or less, that were utilized. This image here is for Pier 17 at the top and Pier 16 at the top. We keep in mind, because this was a mock-up and we were trying to demonstrate the performance of lighting, all the luminaires needed to be able to move forward, backwards, side to side, and tilt. Because a lot of the demonstration, we would be, of course, at nighttime. We had a boat that was chartered, and on that boat, you had representatives from Foreman, you had the Benya and Burnett consultancy, and you also had Burrow Happold, and they were taking measurements at that time to ensure that we weren't having a significant light levels at the water. So as you can see here, we have our piers. So this is Pier 18. This is the gateway pier. And so at the bottom of here, you actually can land onto that pier. And we had luminaires on the bottom here shining up. We had luminaires at the top coming down. On Pier 17, we had luminaires again only at the top, and Pier 16 only at the top as well. We'll get into what luminaire types and the quantity as we move through the slides. This gives you at least perspective. This is the main channel here where the boats and the containers will pass through. As for wireless signals and communication between the devices and low voltage devices, our main transmitter was down here, and we had receivers at the top of both 18, 17, and 16. We tested 2 different protocols, and I'll talk more about that as we move through. And this is to get from basically the shoreline, which was over here, all the way out to this pier. It took about it was a 1.2 mile walk. So you can imagine, to be able to get all of the equipment, which is a significant amount of strut, all of the luminaires, power data supplies, generators, we were basically having to cart everything along that path. So with an army of about, I think we had about 20 people out there making these runs, and we had to be able to really install it within about a 3-week period to be illuminated for only 7 days. So at the top of the piers, you can see this here is at the top of Pier 18. There's a walkway that goes around. Now, keep in mind, the piers are about 180 feet in length, and we have to be able to walk around here, but we got to get underneath of this catwalk, right? There wasn't enough space between this walkway to be able to put our linear fixtures, and certainly not our floodlights, which you actually can see loosely over here, one of the Reach Elites. So we had to be able to come off of this grading here, get underneath to get closer to the facade with our linear lights, and then we still need to be able to adjust it. So we just use this metal plate here, a lot of strut, to be able to swing this entire mechanism up, make angle adjustments to our linear fixtures so that we make sure that we were grazing appropriately, and then swinging it all back down. So that's how we did this at the top of 18, which is different than how we did 16 and 17 because of this walkway at the top of 18. As for power and data distribution, we just had these leftover fabricated panels that we put together using our Data Enabler Pros here, our weather rated boxes where we had all of our 4-conductor terminations, and then power was always done by a generator. So all the power had to be temporary. Because it was a temporary installation, we weren't able to utilize the power that was existing on the bridge. So every single one of these panels we had powered by a generator. So I think we had upwards of about 10 to 12 generators that were distributed throughout the project. Okay, so this is showing you one of the images here. This is at the bottom and the base of Pier 18, just showing you the end generators that were utilized and because of its movement, and that this was being left overnight. If you recall, this is done over the span of about 7 days. So a lot of this material was left out. And being that there really isn't any barrier here, we had to make sure that these were all inside of these plastic grates here to make sure that the generators, as they move, they wouldn't fall off the side. This again over here is showing the picture at the top of 18 and the extent that we went to make sure that we could be able to swing this entire thing up and over. Again, hats off to the construction workers, because there was a lot of things that were unknown that going into this that had to get solved within that 3-week period. Again, this is the bottom of 18. So this is showing the linear grazes all along the bottom of 18. And this is all using the native lens on the MX graze. And from an LED chemistry standpoint, it was important. The royal blue is an important aspect of the project. And so we had our standard red green, but we wanted to be able to have a royal blue, a darker blue. So they have a custom blue chip that was utilized for the project. So this is during the daytime here, during the install at the top of 17, looking at the Pier 18 at the bottom. So you can see some of our generators at the bottom right there. What we had done and tested in phase 1 was along the side here, these 4 little black dots here are actually the color blasts on both sides here to illuminate the exterior front-facing leg of the pier. And then on the interior, we had reach elites, all native lensing. And then again, the whole entire perimeter was the Graze MX. So here, there was one other component of the design set forth by Studio Fink, and that was to create a beacon. And so at the top of the piers, of each pier, that we used a color blast with a louver and a diffuse lens to create this kind of like almost like a lighthouse effect, a visual direct view light source, and that's what you're seeing here. Again, you get a kind of a snapshot of how we utilize the I-beams for our fall protection. Again, more of the plate from the top of 18, and then we get to 16, 17, which I think was pretty fun in the sense that it required a little bit more reaching out off of the pier here, but you get to see the U-bolts that were utilized and how we pushed forward and backwards and forwards and backwards. So the runs themselves were quite long, so you would get a little bit of a sag, but we would brace it at every I-beam possible. And we had them in 20-foot runs. So in a 20-foot run, you'd be able to have two people would be able to be right here at the ledge and then kind of skirt it forward, skirt it backwards. And then this is showing you the first layer. We then put in a second layer so that we can move it left to right. So as mentioned, we had the color kinetic rays, and that we had the Reach Elite, and then we had the blast. So what we did from a native lens is 3 degrees on the Reach Elite. The Graze MX is at 9x9, and then the color burst was, or excuse me, the color blast was a 10-degree beam. So Here you see at the bottom of 18 the extent of all the control equipment, the generators, a lot of extra SO cable, and then of course our data enablers and control. So we did, like I mentioned, test two different low voltage or communications. We tested utilizing a Lumen radio, which was a transceiver that we did for DMX, wireless DMX, in which we had one positioned here and then receiving at the top of 18, 17, and 16. That performed wonderfully. We didn't have really any issues utilizing that product. And then when we transitioned over to an Ethernet-based wireless transmitter and just did a 2.4 gigahertz, set up a little a radio and then an antenna, and we fired it away. Did okay, but we had some issues. We had some shielding, of course, because we were hyper focused on not having any light accidents off the facades. We wanted to make sure everything was guarded as well, as you can see here. And because of the temporary installation, we still had this mounted on strut and then used sandbags to weigh it down, so there wouldn't be any risk of these luminaires falling into the water. A critical component of it was actually our clamps here. As you can see, our C clamps around the I-beam that would hold the significant weight here. And you start to see it gets quite chunky once you start having to create that mechanism for forward, backwards, left to right. And then you can see how close we are, really very close right to the edge here because we had our linear grazes. So let's move on here. The next one. And so we started to be able to actually get significant performance out of it. Obviously, the lighting that we utilized here for 17 and 16, because we're coming down, it's a little bit of shadowing because we are only coming top down, but still performed very well. And a lot of these photos were not edited. And so as you see it here, it's how it performed. So a little bit of a little hot spot down here at the bottom, but otherwise general even illumination that really highlights the architecture. And really the work that was done, 100 years ago. So seeing just the natural color was quite impressive. And here's a view from Pier 18 looking through towards 17 and 16. We had to create this line. This is actually just a rope that had to go around the perimeter of Pier 18 to ensure that there was a barrier, just for the safety of the workers, a visual barrier. So here at this point, there was demonstration for the capabilities of the product. So we ran different color schemes across the three piers. Obviously, we see here static, but we went through a variety. You can see our backgrounds, at least the majority of the presenters today have an orange version of the tangerine version. There's several other iterations. We ran through a significant amount of color testing, specifically in phase one, in which we wanted the Spears and Major had come up with an entire method for going through every single LED value to make sure what if we're going to go for a specific purple, how does this purple compare to the other. We continued that type of strategy in phase two to see how it performed in its real authentic state over water. So there was additional testing that was done, moving through different static colors and then movement, which was really a way to test the wireless signal. And so we would have static colors move from pier to pier with some 2-second fades in and out. And then other times we would introduce sparkle along the top and some integration of that sparkle across all three. And so you see that a little bit here representing the red, white, and blue. Notice, there's one component of the design that was impressive, and I think a lot of us felt that way too, and you see it really best demonstrated in this image and in this image. And as you recall, the four fixtures on the front-facing facade was the color blast, and it provided a little extra tilt. You can see about 60 to 70 feet up on the facade that creates a three-dimensional. It really brings out the text, the architecture and the turn on that corner, providing a little bit of an extra punch. In this picture with the blue, you see it a little bit more. but the performance of the color blast really was impressive for such a small compact fixture. You can see it demonstrated here. So overall, the project again took place over the span of really a month of install and then 7 days of illumination, and then it had to be all torn down. So there was a lot of planning that went into place, and there was a lot of effort put in from ProCal. We had at one point even created a temporary mock-up of one of these piers in the warehouse, and then invited port staff in to see what the actual illumination will look like. And so the extent was pretty intense. As you can see, the amount of buildup from when Studio Fink is chosen to the point of this point. I know there's a lot of anticipation. It was well received, and the data collected for the Coastal Commission was imperative and is crucial to its success. So I know there's typically questions of when will this happen, and that's a loaded question indeed, but we all feel that it will happen. It's just a matter of time. So again, I could not be more honored to be able to present on this, and there's a slew of other people that have come before me and currently working on this that deserve much credit.